talk about the heat of fusion, or how much energy is required to melt something. Okay, how much heat do we have to add to melt something? So you're going to have Q again, which remember is just heat or heat energy. M is your mass, grams, and HF is your heat of fusion, and it's just in a table, and you just look it up. Okay, so you take the mass of whatever you have and multiply it by the heat of fusion. Okay, and the heat of fusion is right here. Okay, and that's all you do. You get the table on your test. The table is on your formula sheet, and so that's all you do. And again, it will also fit in the triangle. It's a really badly drawn triangle. You have M and HF next to each other, and Q is by himself, so he's going to be on the top. You can also do heat of vaporization, or the energy needed to vaporize something, to turn a liquid into a gas. Your Q, again, is still your heat energy. Your M is your mass in kilograms. And your HV is your heat of vaporization. Okay, and this is exactly the same as the other formula, except you have a V here instead of an F. And so then you're going to use the HV part in the table and not the HF part. And remember, this is you get this table, it's on your formula sheet, and it's also you get the table. You do not have to memorize these values. That would be ridiculous. Okay, and this again, just like the last one, will fit in the triangle. I am just really not good at drawing triangles today. The H and the V are together, so I'm putting them together in the triangle. The Q is by himself, so I'm going to put him in the top. Now this is either a heat of fusion or a heat of vaporization, and let's see if we can figure out which one. So it wants how much heat. Okay, that's a Q again. Whenever you see that how much heat, that's telling you it wants a Q, and this is like a heat energy. And it's how much heat is absorbed by 1 times 10 to the 2 grams of ice. So our mass is 1 times 10 to the 2 grams. And if you notice, it's in grams, so we do have to do a conversion, which is kind of annoying, but we can do it. Okay, and then we're saying ice is at negative 20 degrees and it's becoming water. So we're going from ice, which is a solid, to water, which is a liquid. Okay, when you go from a solid to a liquid, that's a heat of fusion problem. Okay, heat of vaporization, vapor is steam, or gas, you're creating a gas. So this one is a heat of fusion problem. So the formula for the heat of fusion problems, it's really simple. It's our mass, H, lowercase f. And let me go ahead and give you your heat of fusion. That way, if I go to the next slide, it'll erase everything. So I'm just going to go ahead and give it to you. But again, this number's looked up in a table too. I didn't memorize it. I've got it written down here. Okay, so that's your heat of fusion, and you'll look it up in a table. And it's really important you get the heat of fusion instead of the heat of vaporization, because if you get the heat of vaporization, you'll do all your math right, and then you'll get the wrong answer because you used the wrong H. So just make sure when you're looking at the table that you get the right one. And I'll show you a table on the next slide. So we have 0.1 kilograms times 3.34 times 10 to the 5. It should be joules per kilogram, and my parentheses should end here, not here. And so if you're one of those people that tracks where the units go, I am, because I like to make sure I get the right answer, and so I track my units. That's how they cancel out. And so when I do this math, I get 33,400 joules. You also might see answers written like this. I'm going to count. 1, 2, 3, 4. Okay, so you might see an answer either way like this on the test as one of your choices. So make sure that you know what the answer looks like both ways. I might practice my scientific notation a little bit so I know that how it looks. And that's all you have to do for a heat of fusion. A heat of vaporization one is exactly the same, except they have a V here, and you look up the H subscript V instead of the H subscript F, but it's exactly the same. And I'll show you this table. So here's a heat of fusion and a heat of vaporization table. This one right here is fusion. This is the HF. It's on the left. And these are the ones, if you're doing a fusion problem, you'll look at these. A vaporization is over here. And so if you're doing a heat of vaporization problem, and that's going from a gas to a liquid, so this one is a solid to a liquid, and that's when you'll use these. And then this one is a liquid to a solid. Or, sorry, a liquid to a gas. And so that's when you'll use the vaporization ones. And that's all.